All right. Now spin it up for going live and verify that it is live. There's a bit of a lag. Okay, and it's live. Let me get that link. Give folks a few minutes to dial in. I know it's the middle of the day on a Wednesday in the US, it's evening in Europe.
It's actually afternoon. It's 4 o'clock.
Oh, yeah, it's still kind of early, even in
Yeah,
Spain, France,
this
UK.
is best. This is the best time for both US and Europe. I think. I mean, if you have teams collaborating and stuff, it's
Yep. All right. I'm trying to do it so it does the view on YouTube where it's a gallery, but it looks like okay. All right. That's sorted. Okay. So I'll get this link sent out. Mark and I'll get started in a moment. We're going to talk about minor extractable value, or on Cardano would otherwise be known as pool extractable value, because the pools operate much like a miner. Okay, all right. Looks good. All right, Mark, thank you for being here today. Appreciate it. And bringing your wealth of knowledge on blockchain. So, minor extractable value, let's start with what is it? What does it mean? How does it work? What is
yeah.
minor extractable value?
Thanks for having me first. Uh, kind of disappointed we didn't include it in the debate yesterday because it was one of the things. But there's lots of misconceptions in the community about what it is, and I think if people would understand what it is, it's they would it's actually they would understand that sometimes it's actually beneficial. Sometimes it just doesn't matter to the average user because it's bots competing with other bots. And third, why it's important to talk about it is because only the application developers are the ones who can do something about it. It's not something that you can really protect against on the base layer. What you can do on the base layer is you can only limit the access to it, uh,
Okay.
not make it impossible completely. So minor extractable value, it's not something that would be very specific to blockchains. It's pretty much an inherent characteristics of every open market where you have uh, visibility and public knowledge. And basically, what it means it's that you can take advantage of somebody broadcasting some sort of information and making either the same deal and block somebody else out of the deal, or or making somebody else or putting an order in the middle. So uh, as as uh, as one example of in layman terms, what minor extractable value could be is that you have two different markets in the same city, and you know the price of some goods on one market. Then you go to a different market, and you see that the prices there are lower than they are on the other one. So what you can do is that you can make a deal between the seller on the market one and the seller on the market B, that you will do so-called arbitrage. That's a beneficial characteristic of any markets, and it's happening on crypto markets, it's happening on exchanges and so on, which is the reason why, if you look at big exchanges, the price of Bitcoin, ADA, whatever, is roughly the same. There is not that much difference between buying, on Binance, buying on Kraken, and buying on Coinbase for price of Bitcoin or price of ADA. But if you look at like Korean exchanges, sometimes during the periods of high volatility, the difference in price on Korean exchanges is much different. Why is that? because there are capital restrictions on the markets in Korea, so it's hard to do arbitrage between global exchanges and Korean exchanges. And what minor extractable value is that when you when you understand that you have the base layer, the blockchain, and then you have the mempool, and the mempool is represents local state, so it's a knowledge available to you. And blockchain, the layer one, it's knowledge available to everyone. Uh, when you are a pool and you receive a transaction from some user, you can look at that transaction, and if it's an arbitrage transaction between two different dexes, you can make sure that you front run that transaction, and as a pool, you mine your transaction first and make the user transaction the second. So instead of the user profiting, for instance, 1 million, he can only profit 500,000, and you take the other 500,000 on the arbitrage. But you need to also have the access to that asset for the transactions, and that's actually where the flash loans come in Ethereum and other blockchains. If you don't have the money to do the arbitrage yourself, and you are a miner, you can make sure that you borrow the money, pay the money in the same block, and use a flash loan. So it gives a bigger, it gives wider access to these arbitrage opportunities to everyone. But if you are the one with the capital, who has his own capital, who has a stake pool that's making blocks, fully saturated one, there is nothing really you can do about it. And it's happening in both blockchains, and it's happening in the typical financial markets. If you look, if but since I think last year, everybody is familiar with the Robinhood, AMC, GameStop, and Citadel relationship, and
Mm-hmm.
something that was discussed a lot in the media was that basically Robinhood is selling the order book to different hedge funds, which then front run your orders, but and it was talked about as a harmful thing, but something that people don't realize. It's the only reason why Robinhood can actually afford to provide service for free without commission, right?
Mm-hmm.
I mean, the saying is, if you are not paying for it, then you are the product, right? And that's always the case. So
Yeah.
so that so that's how you think about minor extractable value. And I think it's more of the thing that you can solve on the layer one blockchain. It's more about the thing that you can solve in the design of your dApp if you are the application developer. So that's one of the reasons that why I think denial about this issue can be really harmful, because if you go with the notion that it's impossible to do on Cardano, or very difficult, you make the developers less aware of it. So then the dApps will not design for it, which will make it much easier to implement. So it's really something that the investors in dApps, users of dApps, should care when they are evaluating the dApp they are either using or investing in. And it's something that the developers should consider when they are designing against around their security guarantees and so on and so forth. In some applications, it may be very desirable to have easy access to MEV. In some different application, it may not be. It depends. In many cases, for instance, if you are running the DEX, as I said, having it very easy to participate in arbitrage uh, can make MEV so accessible that everybody will be doing the MEV. In which case, the normal user will not be harmed at all. It will actually be beneficial, because you get arbitrage for free among different dexes. So the price levels among different dexes will be the same. So it will only hurt financial speculators, but not people who actually, came there to generate the value that you care about as a DEX. You as a DEX still receive the revenue from the trades. So it's actually very, very good characteristic. In the loans, it can be harmful. So it depends about the specifics of the individual application.
Okay. All right.
So
So
uh,
with the application on Cardano, and it would work the same as other blockchains. I'll give a specific example. So let's say I'm operating a pool, and in the mempool, what shows up is 50 to 100 transactions, pretty typical. One of the transactions is arbitrage related, and I could have a bot sort the transactions and say, this one will be more beneficial to me if it goes into the next block. And being a pool operator, you would know when that block is coming, right? So you can keep an eye out for that. And then put them in a certain order that says, yeah, this will be the most beneficial to me, where I can extract value from this block in some way
you
by
can do.
having these transactions included. But what happens is some transactions roll off the book, they won't fit in the block, and they end up still in the mempool, right? Which would censor that transaction if the bot moved it off the list where it fell out of the block and remained in the mempool, and then boom, the extractable value is now available to either the pool operator or the DEX or whoever benefits from that
For
extractable value.
instance, imagine you if all the stake pool operators or Cardano would also be owning a World Mobile token, which would be listed on the DEX. It's
That's
not
a
very beneficial for them to see sell orders with price lower than was their purchase price, right?
yes. That's a
Why
reasonable
wouldn't you
scenario.
censor such a transaction?
If you want to pump the price,
Yeah,
okay,
which you if you own the asset, you probably do, right? Or at least you want to sell first. I mean,
yeah,
imagine you being SPO and a small holder, and you see some whale selling for a huge stack for and dumping your price to 10% of what you thought. Well, at least if something you're gonna sell first, right? Before you include the huge whale order.
you could, yeah. And so you gave me an example before the podcast about apples. Go ahead and go over that example again to kind of reference the market. Remember about your friend tells you they're on sale.
Yeah. As I said earlier, with the markets, you can imagine that you have one town and you have two farmers markets in the same town. And on one market, there is a farmer selling apples for $5 a kilo, and on the other one, you have a farmers market where the farmer is selling the apples for $2 a kilo. So there is obviously an arbitrage opportunity, and you aware of the both prices. You go to the one market, and you see the price. You go, and when you go home to pick up your car to buy the apples and sell them on the other market, you tell your friends, you tell a friend about the great business opportunity you found, but he lives closer to the market than you do, so his car is closer, and he just takes advantage of that order, and he buys all the apples on the first market and start selling them on the second market for $4, right? So
Yeah,
by you disclosing that information, that business opportunity, to your friend before having the contractual relationship with the farmer on the market where it was selling for $2 a kilo, you provided him with opportunity to do that transaction instead of you, right?
yeah, and
So
yeah, and
that
you know, and I know people call it scalping as well. The same scenario is happening with PlayStation 5s right now on the market, where the PlayStation 5s get released at MSRP at 400 US dollars, but the secondary market is so big and so lucrative because of the scarcity that they're selling on secondary for $800. So there's lots of PS5s available for $800 or $900 on all these different exchanges. So there's people making good money. So they get in line and they rush to get the PS5s when they're released by the manufacturers and the suppliers, and then they turn around and flip them onto the secondary market.
so
And
so
it's just another example of how markets and they provide a mechanism for this minor extractable value, just in the context of blockchain. We call it minor extractable value or pool extractable value. And it's not hard for a bot, right? Although you say, well, it's 20 seconds between blocks. How much can you do? Well, to a bot, 20 seconds is a lot of time. It can look at
Yeah,
all
I
the
mean,
transactions as they show up and say, hey, let's
in-
do
I remember the conversations we've been having during the ITN, and we've been talking about latency and stuff. And you may remember me. I was saying that back in the day, I was working for a telco company that was providing connectivity at London Stock Exchange, and
yeah,
we've been basically auctioning slots in the patch panel, which is closer to the London Stock Exchange servers in order to and there you are talking about microseconds, right?
yeah. And
So
so
that's the
and so the preventative measures here is the developer of the dApp needs to be alert that minor extractable value is a possibility, right? And to make and advertise their dApp as being resistant or preventative of minor extractable value,
right. So
or at least the users need to
so
be aware,
first of all,
right?
what they need to do is that they need to consider it in their threat model. For some of the apps, it may be catastrophic. For some, it may be beneficial, and for some, it may be just like I don't really care. It doesn't make my app any much worse, any much better. It's just something that doesn't really matter to me. So
Okay.
that's one thing. If it's catastrophic, you need to rethink the design of the application. You need to think of some way on how to preserve privacy within the application, and reveal the nature of the transaction only after it is committed, and you can verify that the party A, somebody Rick, was the first one who made the transaction. Yesterday, Barry, who is behind the SpaceBuds NFTs, he published a nice way on how to utilize layer 2 protocol to reduce the amount of transactions in NFT mints from minimum of 2 transactions per NFT to just 1 transaction using multi-sig. If your application can be centralized to a point where you are a broker of the transactions and the trusted counterparty, you can prevent MEV by using the multi-sig that the scheme that Barry described, or making modifications on it and so on and so forth. If you have some sort of a centralized element somewhere, uh, then you can fight against MEV. If you want your protocol to be completely open and completely decentralized and always public information, then it's very difficult to protect. I would say impossible to protect against MEV. So you did some research on the MEV on Ethereum. I noticed you shared some articles. I don't know if you looked at the opinion pieces and on the sort of technical solutions that Ethereum teams came up with, but there are basically two schools of thought on the MEV issue. One is like we need to do something to combat it, and the other one is there is not much you can do, or if anything, you can do in general against MEV. So one way to combat it is to give access to MEV to everyone. So if you give access to MEV to everyone, then everyone can profit from it, and the value proposition becomes much less appealing. So the small MEVs won't be extracted at all because it simply doesn't make economical sense. The profit is so little that you are just wasting your time, and the big ones get at least shared among the community as opposed to making rich richer. So
Okay.
that's why there is this Go Ethereum MEV client, which basically every miner, every pool can run. And what happened since then is that the change of the fees on Ethereum, which we debated yesterday. The mining pools of Ethereum at least started to share the profits from MEV with the miners. Before, the pools kept it to themselves. Now they at least share it with all the miners, right?
So now
So
the
so
miners won't
making it
complain.
more making it more accessible provided made it more democratic to access the value created from that process.
Okay. So if the miners somehow, or the pools somehow made the MEV or PEV available back to the stakers, the delegators somehow get rewards out of that, then the delegators would be happy. They'll be like, oh, yeah, I'll make more money if he
Yeah,
employs that technique. And, there is a lucrative market here for, let's say, a very clever developer writes a highly efficient MEV piece of code or PEV piece of code, and then they could sell it and say, "Hey, pool operators, there's 2,000 pool operators out there. I'll sell you this piece of code, for you to use, so you can operate pool extractable value mechanisms." Now,
yeah.
there's a market for everything. If something can be done and it can
Ba-
earn
basically, ba-
revenues, there's going to be a
basically,
market for it.
basically, in order to do it and start doing the MEV, what you need is that you need an ability to monitor mempool. So you would basically have to create your own Cardano node or modify the existing one. It's not impossible with the Haskell node. You can just hook up to the binaries, and then you just monitor. But it's of course better to write your own node, because then you have even more control. But
Yeah.
you can run Cardano node. You can monitor the memory process, and you can extract all the transactions in the mempool uh, into a database, where you can then have a Python program that analyzes the transactions, looks for business opportunities, and if it sees the business opportunity, it will inject a carefully crafted transaction that takes advantage of those other transactions, and then that way you can profit out of that. So some people think that since we have only this Haskell node one official, that it makes it impossible. No, it just makes it a little bit harder, which is the point that I was trying to make. The two school of thoughts in the Ethereum ecosystem, when one tries to make it more difficult, which only means only the oligarchy that has the resources can profit, or the other one that tries to make it more democratic, that everyone who wants can, which
Yeah.
makes it more accessible to everyone. If it's accessible to everyone, it's not all that harmful, right? At
Yeah.
least that's
All
that's
right.
the
So
theory.
yeah, and I'll go back to the my screen share. I'll pull that up for a moment because with every if you have the ability to make money, that money had to come from somewhere. So someone is losing money. So if I'm making more money by doing something, what I call fuckery, right? Sometimes fuckery, good, bad, or indifferent, doesn't matter, right? You're manipulating something to take advantage of it, right?
Oh, it's not
And it can
not
be good or
always.
it can be good or bad. Yeah, not always. But why is it a problem? And I saw that Laura Shin had someone on her podcast to talk about it on Ethereum. I'll just do a quick screen share for people who just dialed in. And that was from Ethereum. I got this from an article. MEV stands for miner extractable value. In the context of Cardano, it would be the same as a pool extractable value. It refers to the extraction of value from Ethereum users by reordering, inserting, and censoring transactions within blocks, which is also possible on Cardano when the mempool is bigger than the size of a block, which it often is now. And the third point, MEV is one of Ethereum's biggest issues, with more than 689 million extracted from users of the network year to date. So MEV can, to some people, it would look advantageous. Do you want me to put that back up, Mark? Are you good? Right.
No, I'm fine.
Yeah. So to some users, it would be advantageous, and of course, to the users who are either not making money or whatever, someone lost out on that deal, then they're losing money. So it's a
That,
double-edged sword. It's there. We need to be aware of it.
that
Uh,
nice thing that nice thing about the Cardano proof of stake model is that because we have this notion of the delegated proof of stake, what we could do is that we could take those 600 millions pretty much and share it equally among the delegators, at least within the network. Which
yeah,
but
kind of.
but that but that that is that will be possible only if we are honest about that the MEV exists within our ecosystem and is possible, and we decide that everyone will do MEV, as opposed to pretending that no one is doing MEV when somebody who has the resources to keep it hidden does it. I mean, there would be ways to to combat it, but not for free. That's all. It would always come at the price, and that's mixing the making somehow the state of the mempool part of the consensus layer. Then if you would have like timestamping on the transactions, and you would use some attestation uh, protocols like uh, interactive protocols probably, then you could probably do something to try to uh, discover some amount of MEV, but it wouldn't always work. It would work only for 20% or 40% or 50% of the cases. It wouldn't work if seven pools would collude with one another, if the order of their blocks would be the right order, and so on and so forth. So it's like you can try to fight it, or you can just acknowledge it and see how you can profit from it as an ecosystem as opposed to an individual.
Okay. What do
So
you think
that's
would what do you think would be the best way forward, as far as the actual dApps itself, or in managing MEV? So, would it be that the dApps advertise, hey, our dApp is MEV resistant? They write it into the code that it either doesn't use, or maybe they advertise MEV is available with this dApp. What do you think?
oh well, advertise. I mean, look, every white paper about certain dApp should have a section that called something like security assessment or vulnerability assessment, where it describes desirable behavior, non-desirable behavior, and how it motivates for desirable behavior, how it tries to dismotivate or make impossible the undesirable behavior. And then one of the chapters within that section should be minor extractable value. And the app developers need to realize what sort of considerations they made, and tell the investors and tell the users how they approach the issue. If they are using layer two scaling solutions, they can protect pretty well against MEV. If they are not, then they can do very little. But maybe my dApp just doesn't really care, because example, NFT marketplaces, they are
Okay.
not that susceptible to MEV, because the tokens on there are unique. So if I have just one copy of every single asset, there is not I, the miner or the pool cannot insert his asset into the trade instead of mine, because he doesn't have the signing keys to that asset, right?
Right.
But if you are talking about DEXs for fungible tokens, if I am trying to sell my 1,000 of World Mobile tokens for ADA, and the miner or the pool has 1,000 World Mobile tokens, he can he can he can sell it for the same price as I do, right? So he can insert his transaction in front of mine because he has the asset. If you are talking about NFTs, he doesn't have the asset. He cannot insert the transaction ahead of mine. So those are the type of considerations you would make when thinking about if MEV poses a threat to your dApp, and if it's something to mitigate or something to encourage. Creating MEV mechanisms between my DEX and my competitor DEX, that's very beneficial, because it will make my DEX earn more on fees. So if I have a governance structure, and I share the profits with my token holders, it will make them earn more revenue. It creates more efficient prices. What is not beneficial for my DEX is one DEX user running ahead of a different DEX user. But for that, you could, if you are willing to have your DEX a little bit more centralized, have that there, that one or two or 10 different parties that run the layer two servers. If you use the mechanism described by Barry with the multisig or something of that sort, you can protect against most MEV, because in that case, if you wanted to do the MEV, you would have to be both the mining pool, plus you would have to be the operator of the layer 2 protocol for that particular DEX.
Okay.
It's
Wow. That
yet to see what Hydra can what the Hydra can do in both the mitigation of MEV as well as taking advantage of different opportunities when it comes to the MEV, because it could be so that you could somehow reorder, insert, and do other things as a Hydra head operator to profit of Hydra head users that use your head to route their transactions, right? So
yeah.
that's another thing that is yet to see, but it could go both ways. That certain use case it could be helpful, certain use case it could be disadvantageous. So you will need to take those things into consideration.
Okay. Yeah. So with the Hydra heads, it inherits the underlying protocol features, so therefore it would have the same feature of MEV. But I think in the case of a Hydra head, wouldn't it be isolated to where whoever operates the pool that the head is attached to, they could reorder the transactions
Well,
with?
you shouldn't be able. Well, yeah. So there will certainly be MEV opportunity to sense. So how Hydra heads work, like you have the state channel, which then you settle with the main chain to dump the state onto the channel. So
Okay.
if you are the pool operator, it may be sometimes beneficial to have one Hydra head dump the state before other Hydra head dumps the state. So that would be like one way to profit out of MEV. Other one is that if you are the Hydra head operator, there is still the the transaction still gets somehow included, committed onto the state of the Hydra channel before the state gets dumped onto the main chain. So there are some things to consider there as well. I didn't do thorough security analysis of that yet. It's not that much of an issue as people try to make it. As I said, it's as I said initially, it's mostly bots competing with other bots, so it doesn't really all that harms that much humans. Then
It's bot
unless
versus bot.
those humans are very rich, in which case I don't understand why they don't pay some programmer to do that work for them and create them a bot.
All right. So Mark, I was wondering if there's another type of MEV pool extractable value that I don't know if it's possible, but would if a pool, let's say the mempool is not full, but there's more transactions than what will fit in a block, which is usually the case right now. So you got more transactions than will fit in a block. And could a bot used by a pool operator be used to sort the transactions so that the highest value transactions with the greatest amount of ADA in them or the greatest transaction fee get processed first in order to get some type of small amount of revenue by.
So because of how the distribution in
Mm-hmm.
Cardano works of the rewards, you as a pool operator wouldn't profit directly
Mm-hmm.
because all the rewards, all the fees over an epoch get collected into a common pool, and then get distributed among all the pools who then distribute it to the delegators, right?
Mm-hmm.
So you wouldn't be able to profit of that directly by ordering the transactions with the fees. So you could make the protocol more profitable, but you couldn't make your only your pool more profitable through consideration of fees.
Okay. Yeah, that is a good point. That is a good design consideration where the pools go into a big pot, or the rewards go into a big pot, and then it's distributed by percent blocks created
Yep.
during that epoch. Yeah. All right. Yeah, good point. Mark, I think that covers MEV pretty well up to this point, and I think as we learn more, if you would like to hop back over here anytime. Feel free. Let me know, man, and we can.
Okay, sounds good. Let's see what emerges within the ecosystem, and once those dApps start appearing on the chain, it would be interesting to look at some of them and make an analysis if they are or aren't susceptible to MEV, and build the knowledge within the community on how to either take advantage of it or how to prevent it, depending on the overall benefit to the community.
There you go. And I have some homework I need to do this afternoon. I need to read up on what Barry Ailes has put out on this
I'll share
subject.
the link.
All right. Thanks, Mark. I appreciate
Okay,
it.
thanks.
I'll get the link posted down below after we're done
Okay,
here.
sounds good.
All right.
Okay,
Thanks,
have a good.
buddy. Bye, everyone.
Thanks. See you.